day, viewers. Welcome once again to Isaac Mathematics Clinic. This afternoon, there is a simultaneous equation we want to solve by the use of the principle change of base, one of the laws of logarithm. So if you look at the equations on the board, in equation 1 we have base 9. In equation 3 we have, in equation 2 rather, we have base 3. So we want to make sure the bases are the same. So according to the principle of change of base, logarithm of xy in base 9, I want to change this base to 3. So this can be written as logarithm of xy in base 3 all over logarithm of 9 in base 3. And this is equal to logarithm of xy in base 3 all over. Logarithm of 9 in base 3 means what is the power to which 3 must be raised so as to get 9. So the power to which 3 must be raised so as to get 9 is 2. So logarithm of 9 in base 3 is equal to 2. So now back to equation 1. Logarithm of xy in base 9 now is logarithm of xy in base 3 all over 2 is equal to 5. So if you cross multiply, logarithm of xy in base 3 is equal to 2 times 5, and that is equal to 10. But before I substitute logarithm of xy in base 3 into equation 2, I have to split it into 2 so that x will be on its own and y will be on its own. Now, according to the first law of logarithm of xy in base 3 is the same thing as logarithm of x in base 3 plus logarithm of y in base 3. So, logarithm of xy in base 3 is now equal to logarithm of x in base 3 plus logarithm of y in base 3, then is equal to 10. I can now make either logarithm of x in base 3 or logarithm of y in base 3 the subject of the formula. So I want to make logarithm of x in base 3 the subject of the formula. So from here, logarithm of x in base 3 is equal to 10 minus logarithm of y in base 3. So, having separated logarithm of x from logarithm of xy now, I can now substitute it into equation 2. So, substitute logarithm of x in base 3 into equation 2. So, in equation 2, in place of logarithm of x in base 3, I'm writing 10 minus logarithm of y in base 3. So that is now equal to 10 minus logarithm of y in base 3 times logarithm of y in base 3 is equal to 6. Then I want to make sure I transfer minus logarithm of y in base 3 times logarithm of y in base 3 to this side so as to cancel this negative. Then I will transfer this 6 to 10. So what I've done is collection of like 10. So this equation now becomes logarithm of y in base 3 times logarithm of y in base 3 is equal to 10 minus 6. But from here, consider logarithm of y in base 3 times logarithm of y in base 3 is equal to 4. And how do we simplify it? how do we simplify this expression? There is no law that guides multiplication of this logarithm. Then what do we need to do? We have to represent logarithm of y in base 3 by any letter we like. So I want to choose A. So let logarithm of y in base 3 equals A. Then this expression now can be written as A times A is equal to 4. A times A simply means A squared. Therefore, A squared is equal to 4. If A squared is equal to 4, A is simply the square root of 4. And A is equal to 2. But don't forget, we represented a particular logarithm by A. So we have to go back to that equation. Logarithm of y in base 3 is equal to A, and A is equal to 2. So this is now logarithm of y in base 3 is equal to 2. And from here, y is equal to 3 raised to the power of 2. Y is equal to 9. Now, if y is equal to 9, then we can easily find the value of x. So we can go back to this equation here. Logarithm of x in base 3 is equal to 10 minus logarithm of y in base 3. Then this becomes logarithm of x in base 3 is equal to 10 minus logarithm of, so instead of y now we are writing 9, logarithm of 9 in base 3. Then logarithm of x in base 3 is equal to 10 minus logarithm of 9 in base 3 is equal to 2. The power to which 3 must be raised so as to get 9 is 2. So you can just write this now as 2. So therefore, logarithm of x in base 3 is equal to 10 minus 2. And that is equal to 8. From here, x is equal to 3 raised to power 8. So y is equal to 9, while x is equal to 3 raised to power 8. Now, we can check if we are right. Now, let's quickly check if we are right. Logarithm of xy in base 9. X is 3 raised to power 8. So that's logarithm of 3 raised to power 8 times y is equal to 9. That is 9 is written as 3 raised to power 2. Then in base 9. Then this is equal to logarithm of, according to law of indices, 3 raised to power 8 times 3 raised to power 2 is 3 raised to power 10. So logarithm of 9 in base, logarithm of 3 raised to power 10 in base 9. Now, what is the power to which 9 must be raised so as to get 3 raised to power n? So let's represent it by x. 9 will be raised to power of x to get 3 raised to power of 10. Then 9 can be written as 3 raised to power 2 times x here is equal to 3 raised to power 10. The bases here are the same thing. Then 2x is also equal to 10. If you divide both sides by 2, x will be equal to 10 over 2. And that is equal to 5 as we have here. So we are very, very correct. Thank you very much for your time. Please kindly follow my Facebook page, subscribe to my YouTube channel for more videos, like, comment, and share. Thank you very much.